Okay, so now what we're going to do is actually add logic to our produce consume. So this would actually be logic that feeds, what we're going to do is design something that feeds the WatchDog. And this will be very helpful to giving an understanding of how to maintain and understand that you have a good connection between two processors. So first and foremost, what we'll do is, now that we have our data in there, what we'll do is the consumed data, or the produced data that we're sending over, and let's go to controller 1. So the produced data that we're sending over this WatchDog, we're basically going to copy that, and then we're going to go to our first rung. And in our first rung, what we're going to do is just simply do an add feature. So in just a mathematical add. And then we'll say this plus 1 equals that. And then what we'll do is we'll also have a bit in front of this. So we'll put a bit in front of this that says if bit 31, which is the end of the line, is actually active, that it will set a clear and clear this data. So at that point we'll go down and just go to get a clear and put that in there. So now let's go get a clear. Actually, let's just do this a simple way. Go here and clear. And so what we'll do here is actually clear that data, and then so now we're just going to have it run, right? So this would be data that's always like running over to the other processor. So if we went to the other processor, we would see that data running. Now what we need to do is do the same thing on this side. So we'll come back and we'll make the same rung over there, right? So first and foremost, we'll add this. We'll put in our bit 31, so kind of a little bit out of order, right? But no big deal. We'll go back and do our add function. So something real simple. Add this plus itself, really, but plus 1, and then again we'll throw in the clear. So keep this very simple, and just type in clear. Okay, so then we'll drag this over here and make sure it's actually working. Okay, so now that's actually producing data over. So now we should go to our other processor and see the data being transmitted back and forth. So now we have something that we're actually talking live to, right? So that now we can come up and say, well, is the data we're receiving, are we getting data, right? Are we talking? So now we have data that we're actually producing over that's actually doing something. So now let's add something to monitor that. Okay, so what we want to do is we want to actually use a compare. So we want to say use a compare, and we could do this one or two ways. We can use what I would do is use a not equal, and then basically we want to use our data that we're getting, our consumed data from our WatchDog, and compare it against itself. Or I'll tell you what we can do is we can use this and use a timer with this. There's several different ways we can do this. Use a timer with this and actually like move some data into it, right? So what we can do is we can move the data into it, and then say if the move stops moving for so long, then we want to initiate a timer. But we can actually take it against itself, say if they're equal, and see if that works as well. So let's quickly do that. Let's just do WatchDog timer, and we'll set this to 1 second. So we'll just do 1 second, and then we'll come up here and do a fault bit, right? So we'll say if that timer is timed out for more than 1 second, then we're not communicating, right? So we want to actually dig down and use the done bit from here. So use the done bit from there, and then we'll say, basically we'll just throw a fault. We'll say com fault. Just something real simple to know that we're not communicating, right? So let's see. So that should actually always work. Another thing you can do is you could actually, even though these look like they're lined up properly, you know, you're really kind of, you're not so much. If I stop producing, I'll show you real quick. If I AFI this over here, you'll see what I'm talking about. So I'll AFI that real quick. So this is not going to move any more data. It's going to stay still. Okay, so this should be, and it's not equal to. So what I need to do is, I need to do is actually push data from here. So and that's why we do testing, right? So what we need to do is push the data from here and load that into, we'll call this WatchDog compare, and this will be a standard dent, right? So then we'll say if our standard dent is, and then we'll actually have to come back and put another rung another rung level right here. So then we'll put this right here, and then we'll move this data, and then we'll say if they're equal to. So let's do that. Let's go ahead and put the compare. We make it do that too. We make it to just change this to an equal to on that side of things too. But in that same focus, this is just as good, just to do this right here. Use this as a not equal. So just use this as a not equal and always transmit data in there. And that way it'll do it that way as well. So obviously that would work. And then come back here and start producing data again. See if it clears up. Okay, so that's not clearing up. So again, so that's, let me see exactly what we should be doing. So what it looks like I need to do, and this is something that I kind of had an oversight on, is what I should probably do is add a clear or a reset for my timer or for my counter. Because if these are moving, then you want to reset this counter, right? So we can go down and put this here, put this here, put this here, and change this here. So that way what it does is basically the timer will always make, and if this is not moving data, then it does not reset that WatchDog. So let's test that feature out. And that was again, that was kind of something that I failed to look at when I was initially doing this. So you see the timer will always stay true, right? But if you're moving data, then it will actually reset, which is a really good way to understand if you're moving data or not moving data. So again, we'll come back and put that there. We'll start moving data again. It should reset perfectly. And then what we can do is we can just basically copy this rung and go back to this. We can paste, and we'll call this WatchDog, right? This will be 1. This will be 1. And this will be a new tag because we're making the new tag. This will be a new tag because we're making it. And then the WatchDog will actually be a new tag. So now we have the system working on the other processor as well. So now if I went and stopped it on the other side, the same thing would happen. So we're basically simulating if we dropped communications, like say for instance, most things would be talking through Ethernet for that matter. And if they dropped Ethernet for some reason, or they dropped communication, then you would fault out just like you did, and you would use this bit to trigger an alarm somewhere or whatever, you know, however you want to do it. This is just one example of a way to do a WatchDog. There's probably a million ways to do it. This is just one example. I wanted to kind of show a way to use the data that we actually made in the produce consumed. So the best way to do that is kind of a WatchDog, you know, to make sure that, because you're going to, generally speaking, when you have two things communicating, you're going to have something as a WatchDog anyway. So it's best you just go ahead and, you know, do that. So now we have both of them communicating and both of them working properly. And again, sorry about that little lapse, you know, because I was looking at it in a different manner. I was going to do actually a couple different ways to show you a couple different ways to do a WatchDog. But realistically, we know how to do a WatchDog timer. And if you don't know how to do a WatchDog timer, just message me below. I can make several different examples of a WatchDog. But this is just one example that is really fast, and it communicates data back and forth really fast using that produce consume tag. So if we look at this, we're producing something out of the WatchDog here, and we're receiving the WatchDog from somewhere else. And again, we can look at that in the other processor. We're getting the same data, so this is the data that is being received, and this is the data that's being produced. So again, so that kind of helps out. And we can, this number again, you can kind of influence. So I can take this to 0 and then have it reset. This is not a number that you can influence at all, because that's being written from a different processor. So hopefully that kind of added some benefits as far as, you know, produce consumed. We can actually, you know, we can do some other stuff if you'd like. Let me know. I kind of want your thoughts on this. I just kind of wanted to throw this in there as just kind of I had some free time and I wanted to talk about produce consumed a little bit more, and then also let you know that it's not really so much dependent on what version you're running. As long as you're running RS Logics, you know, just make sure you have your processors in the chassis. You don't have to use a ProdCon. I just choose to use that because it's easier. So I mean, so you don't have to use, I say a ProdCon, you don't have to use a UDT or a user defined data type. I just tend to use that because it's easier. So whatever you choose to use, hey, I mean, that's completely up to you. I just wanted to you know, have a video out there to kind of, you know, add some value. And I look forward to hearing your feedback and seeing what you guys want to see. So again, thank you for the support, and we'll be coming up with some more stuff to kind of show you, and hopefully everything's going well. Okay, again, thank you, and we'll see you in the next video.